All right, so next up we have David and Sinem, who are going to be telling us about game development and cross-platform development in Visual Studio. Take it away.
Hi everyone, welcome to Peer Virtual C++. My name is David Lee, and I'm the Game Dev Product Manager at Visual Studio.
And I'm Sinem and I am the cross-platform and CMake Product Manager for C++ in Visual Studio and VS Code.
So we've got quite a lot in store for you. Whether you're a game developer or not, we will show you how Visual Studio is the fastest yet. Of course, over the past years, we have been working hard on building first-class Unreal integrations into Visual Studio so you can spend more time in Visual Studio without switching back and forth to the Unreal editor. Sinem will cover some cross-platform tools that allows you to target Mac or Linux. And of course, we'll showcase a variety of our latest productivity enhancements. But before we begin, I'd like to thank you to everyone who gave us feedback on social media and developer community. A lot of your suggestions is what made this available today. So let's get started with performance. You can open Visual Studio faster, get to your code, and of course, it's more responsive and spend less time loading. As you can see here, we benchmarked Visual Studio using a real-world AAA Unreal Engine 5 game, which is a large code base. And for several scenarios, there is a code and a warm distinction. Code just means that you're opening up your project for the very first time. Warm means you have opened your project previously. Visual Studio has done indexing and all the other background activities. You can see here, we made significant improvements in reducing the time it takes to parse your C++ solution. It used to take almost 280 seconds, but now is around 90 seconds. That is a 3.2x faster improvement. Of course, we have continued to improve our solution load scenarios. Here you can see we also made great improvements for the solution close scenario. What used to take 4 seconds to close for the first time takes only 2 seconds. Similarly, for the warm scenarios, where both scenarios are now about 2 times as fast. We have also focused on areas such as C++ colorization and the speed of searching C++ code. These scenarios are just a fraction of what the team is working on. And of course, it only counts for improvements since VS 2022, 17.2, which is the last we've talked at Pure Virtual. And of course, Visual Studio 2022 will still be focused on performance. So next year, you'll see even more performance improvements for your large code base or Unreal Engine games. Some of the productivity tools that has arrived in the past year are meant for game developers. This one specifically is meant for game developers who work with shaders. We partner with the extension HLSL Tools, which is a very popular shader editing extension made by Tim Jones. As you can see here, you can open your shader file and be presented with full IntelliSense, as well as colorization. You can navigate throughout your shader files with go to definition. And of course, this not only works for HLSL, but also for Unreal's shader files like USH or USF. And of course, Unreal Engine integrations, something that a lot of Unreal developers have been waiting for. We heard a lot from both our community and our first-party studios about how they want to do more in Visual Studio without having to switch back and forth between the Unreal Editor and Visual Studio. That's creating mental strain, and because you have to mentally task switch every time. let me show you how an Unreal developer can use Visual Studio today to enhance their Unreal Engine development. Starting with Unreal blueprint references. Let's say your gameplay artist or level designer handed you a bunch of blueprints. In Visual Studio, you can now see your blueprint references with colons hints. Once you click the blueprint references, you can select your blueprint, double-click, and open the asset inspector to see your property and values of the associated assets. You can collapse, you can sort, you can filter to see different properties. This will allow you to spend a lot less time, so you don't have to go and hunt down the blueprints in the Unreal Editor. Next, macro expansion for C++. While this has came from Unreal developer feedback, this is useful for all C++ developments. Unreal engines sometimes can contain complicated macros that may be hard to memorize if you're just looking through a code. Now you can hover over to inspect and copy or expand in line. Next, we have Unreal Engine macro formatting rules. This is a special enhancement just for Unreal Engine because the way UE macros work. As you can see here, the indentation is not what you like if you're familiar with Unreal Engine projects. By going to Tools Options and searching for Unreal Engine, you can apply a special formatting rule for slate declarative intacs and Unreal Engine macros. Now here, I can backspace, and of course, the macros will be indented like you wish. And of course, with Control-K and Control-D, you can indent them all at once. New to this year is all-in-one search. With all-in-one search, you can search your symbols and features in the same place. As you can see here, I searched for a Lyra player controller that opened up my search results as well as a code preview window. In the code preview window, you can perform simple refactoring options or navigation. But not only that, this is also a feature search for Visual Studio. You can misspell because we do support fuzzy searching. So if there's a specific Visual Studio command you forget, you can search for it. We have started building a host of code analysis tools just for Unreal Engine. First is exposing the Unreal Engine, the UHT, Unreal Header Tool warnings into Visual Studio. Upon save, let's say you made some mistakes. Before even compiling and seeing the errors, Visual Studio will run the UHT and put all the warnings that UHT found into Visual Studio. But we're not done. The newest code analysis is the naming convention checker. If you add a .editor config, which will provide a link at the later portion of this talk, you can give a naming rules for your Unreal Engine projects. And let's say you have cat player character. Now, with Unreal Engine, because this is an actor, Unreal Engine naming convention states that it should start with a capital A. You can click on the quick tooltip and apply your changes. Lastly, we have Unreal Engine log streaming. To open the log streaming window, you can go to View, Other Windows, and Unreal Engine Log. Here, I've added a warning log that basically prints something every time a weapon is fired. I misspelled laser. Thank you, spell checker. So save, and let's compile this. Once you're in the game, you can go and test your game Now, instead of having to keeping your Unreal Editor open or close it and lose your logs, you can now see your Unreal Engine logs in Visual Studio. Once you go to the Unreal Engine log tab, you're presented with a view similar to the output window. You can filter on processes, your different categories of logs. Here, I have a lot of extra logs. So let's filter them out. And of course, for verbosity, my log that I created was in warning, so let's only show those. Some other functionalities allow you to remove the timestamp, toggle read only, toggle word wrap, enable, disable auto scroll, clear, save, and of course, navigating your error messages. Not only can you open up with a debugger, you can also press the red record option to capture an Unreal Editor that is already in progress. So there you have it. A bunch of Unreal Engine support aimed to make your Unreal Engine development even more productive. You can do less context switching, less switching back and forth in Visual Studio. And of course, we're not done. So keep your eyes out as we continue to develop even more Unreal Engine and C++ productivity features throughout the year. As I mentioned before, here are some of the resources that you may need to get this started. For blueprint references and asset inspector, you'll need the Visual Studio integration tool, which is an Unreal Engine plugin. You can see the source code at aka.ms/vsue GitHub, which we have open sourced. Or if you're a developer who gets their Unreal Engine from as a whole from Epic Games, we have also a marketplace page where you can download the plugin. Lastly, if there are any troubleshooting, you can go to aka.ms/vsue troubleshoots to perform some basic troubleshooting steps that you might see. For the naming convention, you can go to aka.ms/ue naming convention to get a sample.editor config file. Once you have a .editor config, you can drop it into the root of your solution. Lastly, for more details, please see all of the game dev blogs that we have posted. And a quick link, aka.ms/cpp game dev blogs will take you to all of the game dev blogs we have on our C++ team blogs. So Sinem, tell us about how we can expand game development, not only from Windows, but to Linux and Mac as well.
Yeah, so a common problem that we hear from game developers is their need to target multiple platforms or utilize Linux servers to power the backend game services. So even though developers do prefer to develop on Windows and are comfortable with that and love that Visual Studio tooling, they want to make sure they're able to target multiple platforms using that same Visual Studio tooling. So some common feedback that we have received from cross-platform game developers is that they want to utilize the same debugging tools for all their different types of OS and architectures. So they don't want to spin up different types of workflows for the different OSs that they're working on. They just want to have that same no context switching mindset. Additionally, they want to ensure that their game is consistent across multiple platforms. So when they are debugging and running their game, they want to ensure that there is a visualizing element to that to ensure that everything is looking properly and working properly. Also, we have gotten some feedback from cross-platform game developers that in some scenarios, using Linux servers can be cheaper, faster, and there is no extra hardware required to that. So they want to use Linux servers to power their backend, which creates a cross-platform need. To address these common feedbacks, we recommend that you use the following tools to maximize your C++ cross-platform workflows from Windows. So first, we recommend that you use CMake as your build system. And what CMake does is it allows you to specify CMake presets for each target OS. So if you have Linux as your target OS. You can specify different presets for that, and Visual Studio will automatically dynamically update and scope based on what machine you're targeting the CMake presets that are available for that. What CMake also does is it automatically generates build scripts for specified compilers and platforms in your preset, and it is highly customizable. So if you want to add any sort of build arguments, or if you want to add any sort of metadata, you're able to compile that in a CMake preset, and that will be centrally managed in your C++ repository. Now that you have CMake as your build system, you can use your target machine as Windows subsystem for Linux or WSL. What is great about WSL is that it allows you to run Linux tools from Windows without having that overhead and maintenance required with traditional Linux VMs. And it has a super simple setup. So whenever you're on Windows, you just have to run a few commands to get WSL spun up. It integrates really well into Visual Studio, so you don't have to manage a separate connection and ensure that your keys are all correct. It'll just integrate right in and be automatically detected, but also integrates into other Windows applications as well very seamlessly. WSL can be faster, more lightweight, and efficient than traditional Linux VMs as well. So it can be really great for very heavy game development. Then, once you have CMake and WSL in your workflows, you can then use Visual Studio, which David showed earlier, integrates really well with Unity and Unreal Engine. So it really has that great game development background. And it also provides that really powerful debugging and cross-platform targeting. So you can use Visual Studio with CMake and WSL to have that full debugging suite. To show you the power of using Visual Studio with CMake and WSL, we have a short demo today. So what we want to answer with this demo is, how can I extend Visual Studio to run my game service on Linux server while having the tools of Visual Studio, and how can I debug my remote processes? So in this example, we have a Snake game that Udacity created for their C++ course, and this can run on Linux, Mac, and Windows, and it has some library dependencies for the graphics. So what we did is we cloned this into our Visual Studio repository, and I'll show you in this demo sort of how you can have that same debugging workflow from Visual Studio. So let's take a look. So I have it cloned, and I've already downloaded WSL, and it'll automatically detect that WSL machine and scope down my CMake presets based on that. So my Linux preset is shown. Then from there, I can set a breakpoint in my code, and there's all sorts of types of breakpoints that you can set. In this case, I'll set a conditional breakpoint on when the snake speed exceeds a certain threshold, but you can set all sorts of different types of conditions as well. And with the new dependent breakpoint, once that conditional breakpoint is set, I'll set another breakpoint on placing the next snake food once as a dependent breakpoint. So once that condition is met, this next breakpoint will be set. And this will apply to your Linux workflows or Mac workflows, and you can accomplish that all from Visual Studio. As you can see, as I'm scrolling, there is also that docking going on at the top, and that is a new feature called Sticky Scroll. And that allows you, when you're embedded in, very nested functions, to view where you exactly are in that function. So it can be really great for your debugging needs as well. So once WSL is targeted with my CMake preset, I'm able to press play, and you'll see that the game is running on my WSL machine, and I'm able to visualize that from Visual Studio. And once the snake speed gets fast enough, which is right here, I'm able to view the state of local variables, and the debugger is able to break on that dependent or conditional breakpoint. So that can be really useful. And now that that snake speed is at that threshold, the dependent breakpoint I set on placing the food will break the next time I have to place food. So you're able to view a lot of different things and incorporate these into your debugging workflows. But if you have this WSL machine, you may need to have an SSH integrated experience with a terminal. And so this is where the integrated terminal comes in handy in Visual Studio. What the integrated terminal allows you to do is have an SSH interactive terminal in Visual Studio, and you're able to do things like manipulate files, fire off processes, and that way you don't have to go navigate over to your terminal and manage all your SSH connections. It's all able to be accomplished within Visual Studio. So let's take a look at how that works with my snake game that I showed earlier. So to open the integrated terminal, what you'll do is you'll go to View and then Terminal. And then from here, you can select any machine you want to open up. So I'll just open up that same Ubuntu machine from before. And from here, I can fire off, for example, that same game and build that game and run any of those processes. So I'll run the commands to run CMake on it from the command line and then make the executable. So we're able to accomplish that all from the integrated terminal and then run the game, and you're able to see the similar output of the snake game running on the Ubuntu machine. So this can be really great for any sort of Linux workflows because you're able to interact with the terminal from within Visual Studio, and it supports I/O. So this was a pretty simple example of how you can utilize the integrated terminal, but there's a lot more you can accomplish with it as well. So without having to leave Visual Studio, what you can do with the integrated terminal is manage and enable SSH connections on your Linux machines. You can also manipulate files and run background tasks that you need to have running. You can also configure your remote system from the integrated terminal within Visual Studio. Plus, now there's a new added support for Linux consoles. So any of your Linux console apps, you can also debug from the integrated terminal, and it'll emulate an Xterm and support screen application manipulation. So this can be really great for any of your Linux workflows with the terminal. So at this point, we've walked you through how you can use Visual Studio to debug your Linux applications. But what if you have a process that's already running that you haven't had it? It's either in a broken state, you haven't fired from Visual Studio for any of your needs. Can I still debug from Visual Studio? So to show you that, we have attached to process. And there's other sorts of advanced debugging applications that allow you to debug from Visual Studio and debug Linux core apps under the debug dropdown. So let's take a look at how attached to process works. So I have this snake game running that I fired off separately from Visual Studio, and it's on my WSL machine, but you can attach to really any sort of remote process that you have running. So to do attach to process, you'll go to debug and then attach to process. And from here, this pop-up will show up and you can connect to any of your machines. So for example, it'll be my Ubuntu machine from earlier, and it's going to be a WSL type. And any of these processes are available for debugging. So I'll attach that to that snake game. And then I'll attach a GDB debugger. And so since I have this code open in Visual Studio, it'll break on the breakpoint that I set, and I'll be able to view modules, I'll be able to view symbols and local variables. So attach to process can be really great for really any process that you have running on a remote machine. And you're also able from that debug dropdown again to debug Linux core dumps, which, for example, Blizzard had used for their Diablo 4 debugging. So really exciting stuff for your complicated game development workflows. So today we walked through how to use Visual Studio to debug your remote processes, but we actually have some new exciting cross-platform tools as well that you can use for CMake and WSL that we didn't get a chance to show. So the first is the CMake debugger, which allows you to debug your CMake scripts at configure time. To learn more about how to use the CMake debugger, you can check out aka.ms/CMake debugger video. And that's a short demo on how you can debug your CMake scripts whenever they get a little complicated. And then you have the Remote File Explorer. And what's great about the Remote File Explorer is you're able to view, upload, download, and search files on your remote machines without having to navigate to a separate file manager or having to navigate to that specific machine. And to learn more about that, you can check out aka.ms/Remote File Explorer video. So what did we learn today? We learned about how you can utilize Visual Studio for all your OSs and visualize your game flows while utilizing Linux servers and CMake with the CMake and WSL integrations into VS for cross-platform debugging. So you don't have to have a different workflow. It works the way any other application would within Visual Studio. We also learned about the new dependent and conditional breakpoints. So how you can set dynamic breakpoints from Visual Studio if you want to have your code break on a specific condition or specific dependency. We also learned about using integrated terminal and VS to SSH into your remote machines and have that interactive experience and fire off processes, which we saw with that snake game. And lastly, we learned about attaching a VS debugger to processes running on your machines and others. So on your local machine or remote machines, you're able to attach a Visual Studio debugger too. So that functionality remains the same, and you can incorporate that into your game scenarios. I'd like to thank you all for coming to our talk. We love interacting with our customers. We love responding to your feedback, and a lot of these features have come from direct engagement with customers. So if you have any sort of feedback for us, anything you'd like to see in CMake or in Visual Studio, but also across the board for C++, please reach out to us via email at visualcpp@microsoft.com, and then follow us on Twitter for any of the latest stuff that we're working on or to interact with us. So our team is at Visual C. David's is the CPP PM. And then I am Sinem__Akunja. So thank you so much. And we're here to answer any questions as well.
Great. Thank you so much. I have Marshmallow here who very much enjoyed your talk. We have a couple of questions in chat so far, and folks can feel free to continue dropping them in. If you want to ask any questions, please do make sure you're at the Visual Studio YouTube page. So we got a question here for David. Do the solution close C++ colorization and search performance improvements also affect CMake and Ninja projects?
The performance improvements is it'll affect anything that is C++ based.
Cool. And another question is that the log filtering tool looks really useful. Would something like that be possible for other types of projects, like a plugin or something like that for non-Unreal projects?
For non-Unreal projects, please give us your thoughts in the developer community, as we're interested in hearing how a variety of features can make you more productive. So while we don't have anything planned on our roadmap for other projects or plugins, do let us know your specific scenario and the type of plugins you're working with. So let us know, and we'll do our best to prioritize according to community feedback.
Great. We don't have any more questions yet. So I just want to point out how much of a absolute fluffball Marshmallow is. He's like that anytime I have a call or try to run a conference or anything. He wants to be the center of attention. We have, we're about at time. We can maybe take one more question if anyone has any, or we can move on to our final talk of the day. I'm just checking that I got my times right. Oh yeah, we got 5 more minutes, so we're okay. So any more questions, let us know. I'm interested, the CMake debugger stuff, we upstreamed that, right? So what does that look like? Like what can folks from across the industry use?
Yeah, so our work has been committed upstream very recently, I think, as of last week. So you're able to fork that then and develop your own sort of CMake debuggers or any sort of features that you want to add to the functionality, which is really exciting. And for example, we'll look to then use that forked repo for VS Code CMake debugging. So I think it'll be a lot more accessible and it'll be developed on a lot better. So I think there's a lot of exciting stuff coming from that upstream contribution.
Yeah, it's very cool. And yeah, it's something that I've always wanted when debugging obscure CMake issues.
Yeah, I think it, again, a lot of customer feedback was, you know, we want to take a look into this CMake language and be able to step through it. And I think that it's really great in that regard. So I'm very excited about it as well and hope anyone using CMake is able to use it. So.
All right. Well, it looks like we don't have any more questions. So thank you very much for your talk and your time. And we will move on to the last talk of the day.